Hello everyone. So, if you recall last time, we were looking at the different properties of the parallelogram, and we saw that knowing that something is a parallelogram gives us a lot of information here. So, not only does it help us in numerical problems, it also helps us in proof. So let's take a look at an example of this one here. So as you can see here, we want to show OP is congruent to OQ here. So I'd like you to, again, just take a minute, go ahead and look at this here and see what you can come up with for this. Alright. So, it's pretty clear here that we want to focus on a pair of congruent triangles, and this is where our congruent triangles kick in here. So we kind of have this thing here. This seems to be pretty straightforward, right? We got these two things here. We're also given JL is congruent to OL. Alright, so let's see what's going on here. Well, the first thing to note is that we have a bunch of vertical angles here, right? In fact, actually, JOP and QL here are vertical angles, so they're congruent here. We can march that. And we also seem to have the fact that, this is a parallelogram. So we can utilize the fact that parallelograms have parallel sides. Looks like I've got this here as well. So this pair of angles, KJO and MLO, are congruent here. We can set it up that way. Now, note, you could have also used the other pair of angles here. That's perfectly fine. But no matter how you slice it, it's still going to end up this way here. So, as you can see here, a proof of this shouldn't be too hard for us to write. So I'm going to write this out in paragraph form. You can write this in two-column form as you choose, okay? So we're going to start off with the fact that, in this case, I'm going to use angle side angle here, right? So we can say that we are given that JKLM is a parallelogram. Now, note that in this situation here, we want to show the fact that these two angles are congruent, and they're congruent because we have parallel sides here, right? We have this case they're parallel, right? JK and ML are parallel, so as a result here, they're parallel because this is a property of the parallelogram. So, and we know in this situation, when we're mentioning the properties of a parallelogram, we have to mention the exact property we're using here. So, we can say that since opposite sides of a parallelogram are parallel, we know JK is parallel to ML. So note here, ladies and gentlemen, that I'm going to write this out in red, so you can see that we have here opposite sides of a parallelogram are parallel here. We want to make sure that whenever we state a specific thing here about a parallelogram that helps us with our proof, we have to make sure that we explain why that's the case here. So in this case, opposite sides are parallel parallelogram. Opposite sides of a parallelogram are parallel. My apologies. Thus, since angle KJO and angle MLO are alternate interior angles, angle KJL is congruent to angle MLO. And that's a pair of angles here, right? So we note that we have this sort of thing going on here, okay? All right, now we can just continue our introduction here, right? We are given JO is congruent to OL. And now we have our vertical angles, so we're going to go ahead and mention them. Angle JOP is congruent to angle LOQ since they are vertical angles. And that's another pair, that's an angle there. So now we have angle side angle. We can go ahead and put this together. So we can say thus triangle JOP is congruent to triangle LOQ by angle side angle congruence. Therefore, we can now finish the proof here because now we're trying to show OP is congruent to OQ. We can finish the proof here. We can say therefore OP is congruent to OQ since corresponding sides of congruent triangles, right? So you can see what's going on here, are congruent. And we are done. So as you can see here, what we're doing so far with this is pretty straightforward. We're able to just simply adopt what we know about parallelograms here all we have to do is just make sure to explain it just like we would any other thing, and we'll be just fine.